Hi there, I'm Ross, and this is one of my favorite types of problems because it takes a really common math concept and puts it into the real world. So looking at this problem, we're talking about a ball being dropped from the top of a building that is 1,000 feet high. Its height in feet as a function of time, which they're calling x, and that's measured in seconds after the ball was dropped, is given by the equation f of x equals 1,000 minus 16x squared. And all they're asking is what set of numbers is appropriate as the domain of the function. So first, just a quick review if you can't remember, domain is all of the x values that can be substituted into a function. So it's every single number that you can substitute in and get an answer back. And you may think like, well, you could substitute anything in, but there's some functions where that doesn't actually work. There are certain numbers that won't give you an answer. In this equation, you'd actually be right if you said any number will work. Every single number in the universe, any real number will give you an answer here. So technically, the domain, I'll put D equals, we would say is all real numbers. So you can write that out. You can write all real numbers. Or one way to write this is you can, in interval notation, write negative infinity, comma, infinity. And that just means every single number in the universe, all real numbers, can be plugged in or substituted and give you an answer. However, this is not talking about just that function. If that was the case, any number would do. In this case, they're specifically talking about the scenario where you're throwing the ball off the roof. And in that case, this domain's not really going to make sense, and I'll show you why. Keep in mind that because this function has an x squared term in it, we're talking about a quadratic, which has the shape of a parabola, this kind of U shape. And because the coefficient in front of the x squared is negative, it's actually going to be an upside down parabola. So I'm going to go ahead and sketch that real quick. It's not going to be pretty, but we'll do something like that. And these arrows indicate, that is actually kind of pretty, these arrows show, like we did in this domain, that the function will actually keep going forever and ever and ever to all possible x values. But let's think about what this would mean in the context of this problem. This vertex up here, the very, very top, which is actually also the y-intercept in this problem, would actually be 1,000, because when x is 0, when we plug in 0, the y you get is 1,000. What does that mean in this problem? That has a direct connection to what we're talking about. In this case, that's the height of the building. So at 0 seconds, right before you've dropped the ball, that height of the ball is 1,000 feet. Also important to recognize that this graph is not the path of the ball, right? If you drop a ball, it's not going to somehow fly off in an arc. It would go straight down, then bounce back up, then straight down, then bounce back up, right? Maybe a little lower. But in this case, this graph isn't showing you the path of the ball. It's just telling you how high off the ground it is after a certain amount of time. So what's next? Well, if we want to know the domain, we got to think about what values would make sense. First of all, I'm going to eliminate every number to the left of the y-axis. And think about why that might be. Keep in mind, x means seconds after the ball was dropped. Why would I get rid of all those negative numbers? Hopefully you're thinking, if I'm dropping the ball at 0 seconds, nothing happened before that, right? It doesn't make sense to talk about the time before the ball was dropped. So I'm getting rid of every single number before 0, because we can't go backwards in time. Wish we could. What else, though? There's still another piece of this that I'm going to get rid of. Keep in mind, x is seconds, and this y-axis, you're talking about height, right? I'm going to put h for height. So what other piece of this graph might we get rid of? I'm going to get rid of everything now below the x-axis, rather. And why would that be? Well, if down here the x-axis is 0 feet, it wouldn't make sense for the ball to go below that, right? Unless somehow it's going into the ground, but I don't think that's happening here. So we're getting rid of everything that would be negative time, all the x values left of 0, and everything that would be negative height, so below the ground. So now that means that we're going to revisit this domain, and we're going to start at 0. So I'm going to put d equals 0, comma, but where is this going to end? Well, for that, we would have to figure out where is this point, because that's going to be the time, our x, where the ball hits the ground. Now, maybe you've done problems like these, maybe you haven't, but the easiest way to go about this is just to say, well, I have my equation, 1,000 minus 16x squared, and I'm going to set that equal to 0, because I'm trying to figure out where this point is. I know the height, right? This y value should be 0. The y is the same as the f of x, and that's all I've really done is replaced it. And I want to know what is this x value right here that would give me that 0. So now I have an equation I can solve, and I'm going to go ahead and do that. In this case, I'm going to subtract 1,000 on both sides to isolate my x term. I do not like that color. Let's try purple. So I'd have negative 16x squared equals negative 1,000. Then divide by your negative 16 because we're multiplying by that x squared, negative 16, and then x squared is equal to, remember a negative divided by a negative is a positive, so this is just going to be 1,000. Let's try that again, 1,000 divided by 16. And I'm leaving it like that for now instead of dividing it, just because I don't want to mess with a messy decimal. And then the last thing to do, because I want x, not x squared, is I'm going to take the square root of both sides. Now this is always where my students make their most common mistake. The square root and the exponent will cancel, so that'll leave us with x equals, and the value you should have is about 7.906, but that's missing something. This is what my students always forget. Because we took the square root, we have to put our plus or minus in front. Because if we take a negative 7.906 and square it, we'd get 1,000 over 16. Or if you take a positive and square it, you get 1,000 over 16. So there's actually two answers here, which corresponds to these two x values where our graph hits 0 on the x-axis. On the 0 on the y-axis. So we have two x values. Which one goes here, right? We only want one of them. Well, go back to the fact that earlier I actually got rid of all these negative x values, right? We said even though technically those would work in this function, in this problem that doesn't make sense because we can't have negative time. So even though there are technically two answers, we're going to go back and get rid of that negative one. So all of that to find out that appropriate domain, right? Technical domain is all real numbers, but our appropriate domain talking about the height of this ball would be 0 to 7.906 seconds. At 0, you're holding it at the top of the building. At 7.906, it hits the ground. So I hope that helps, and hopefully that'll help you to do some other problems in the future.